In this video, we'll discuss the process of solving a linear inequality. We'll compare this process to solving a linear equation and work through a few examples. To start, we're asked how this process is similar to solving a linear equation, and we're asked how it is different. The key is that the process of solving a linear equality is almost identical to the process of solving a linear equation, with one exception. So to start, let's talk about how they're similar. The first thing is that we can add or subtract the same number from each side of a linear inequality. This will result in what's called an equivalent inequality and will help us find the solution set. The second thing is that we can multiply or divide each side of a linear inequality by a positive number, and that's a key point here. And again, by the same positive number. Which, highlighting that positive number aspect, should key us in on the difference. So the key difference, there's one, is that if we multiply or divide each side of a linear inequality by a negative number, we must reverse the sign. And I'll show a couple examples of what I mean by reverse the sign, but in short, if it was less than, it will become greater than. If it was greater than, it will become less than. This is a key distinction in that an equal sign, there is no reverse of it. It's just the same either way. So let's look at one quick example here. Let's look at adding or subtracting first. So if we had something simple like x plus 5 less than 2. To get x on its own, I'd subtract 5 from each side. So I'd have x plus 5, I'd subtract 5, and that'll be less than 2 minus 5. That will simplify down to just x less than negative 3. So an equivalent inequality there. So that is similar to if we were to solve the equation x plus 5 equals 2. We can add or subtract from each side, and it'll result in an equivalent, in this case, inequality. As another quick example, let's look at 2x less than or equal to negative 8. Now, to get x on its own, I want to divide each side by 2 since I have 2x. Now I'm dividing by a positive 2, so I'm going to take 2x, I'm going to divide by 2, and then I'll also do that on the right-hand side. So that'll be less than or equal to negative 8, and that will be divided by 2. Now what I did here was I divided by the number 2, which is positive, so there was no reverse of that sign, and I just get x less than or equal to negative 4. So those are two examples that would work just like equations. The last one we'll look at will involve having a negative coefficient on a variable, and so we'll have to either multiply or divide each side by a negative, and that will reverse the sign. So let's take 4x, and let's make that negative 4x, greater than 20. So I have negative 4x greater than 20. I want x on its own. To do that, I'll need to divide each side by -4, and because I'm going to divide each side by a negative, that is going to reverse my sign. So I'll have -4x over -4. That greater than sign will now become a less than sign. And on the right side, I'll have 20. I'm going to also divide that by a -4. So I've done the same thing to each side. I've divided each side by a negative, but that greater than sign reversed to a less than sign. And so now I'm left with x on the left, and that's simply less than a -5. There are various ways that the solution sets to these inequalities that we just solved can be represented, which we'll go over in later examples.